There's a new AI image generator out called Flux 1.1 Pro. But what's interesting to me is that it has an API. I can access it programmatically. In a recent video, I showed how to do that with Java, but now I want to do it with Kotlin because Kotlin has some built-in mechanisms specifically for working with asynchronous APIs like this. Welcome to Tales from the Jar Side. Welcome. My name is Ken Cousin, and on Tales from the Jar Side, I try to give you expert advice on working with Java, Kotlin, Groovy, Spring Framework, AI, and related topics. This time I want to talk specifically about a RESTful web service, and it's announced here. So this is from Black Forest Labs, and it's called Flux 1.1 Pro. Now, normally a new AI image generator wouldn't be all that interesting to me, but as I mentioned, this one has an API now. But let's take a look. If I scroll down, then you find out that it has this ability to access it as a RESTful web service. And in fact, they even cut down the price. For Flux 1.1 Pro, it only costs 4 cents to generate an individual image, and that's less than the 5 cents for Flux 1 Pro, even if you could access it. Over here is the documentation page, and they talk about how they've got the various endpoints, and you have to register and get a key and set that key as an environment variable. All of this is quite normal. Then you want to access it. But the interesting part is here. First, I'm showing this in Python form, but the basic idea is that you simply access the Flux Pro 1.1 endpoint with a post request, submit your key and your accept and content type headers, and here's the prompt, the cat on its back legs, etc., with a width and a height, and that returns an ID. That's what makes this asynchronous. Rather than blocking and just waiting until an image is ready, this returns immediately with an ID and starts generating the image in the background. So what they want you to do after that is go to a different endpoint called getResult with a get request and the ID as a query parameter on your request, and then wait to see when it's ready. They actually recommend you poll it, like in the little sample here, it's every half a second. And what'll come back in the result is some status property that'll go through a series of values. Eventually it'll be ready, and then you could dig down to the result, and inside the result there's this sample field that has the URL of the image, and then you could download the image. So there's a 3-step process going on. The first step is you ask it to generate an image and get back an ID. The second step is that you poll the getResult endpoint with that ID, waiting for the status to be ready. And then the third step is that when the status is ready, you can take the URL it returns and then download the image. Now, I want to do all of this in Kotlin because it makes it really easy to do asynchronous services like this. Before we go to the details of the code, let's take a look at the details of the API. Now, just looking at the samples is a good way to get started, but it doesn't have everything in it. What they do provide is an open API, what we used to call Swagger document, a JSON document that documents how the RESTful web service works. So let me just show you the important parts. First of all, to generate an image, here are all the fields that you can submit. You do have to submit a prompt and a width and a height. Now the width and the height default to 1024 width and 768 in the height, and the values can range between 256 and 1440, and they have to be divisible by 32. Interestingly enough, it's like odd little requirement, but so be it. You can set this prompt upsampling field Boolean, which will allow it to rewrite the prompt if you wanted to. You can put in a seed if you want to get the same image back multiple times, just use the same seed over and over again. And then there's a safety tolerance used for moderation. Again, the result of that is just an ID. Now, when you go to the getResult says just do a get request with that ID on the query string, and you get back an ID, a status, and a result. And this is where things get a little vague. Now, if you look at their so-called models, the async response is just the wrapper for the ID. So that's the one that comes back from the initial generation. Then the Flux Pro 1.1 or 11 looks like here, inputs, has all those fields we just talked about in it. And if you look at the response, that is this guy called result response. So there's the ID, there's a status, which looks like an enum, 6 different options there, including ready and pending, which are the ones we care about. But if you look at the result, now it all gets vague. It could be null, but it also is an object, and they don't explain what's inside that object. That's what I wonder if they're eventually going to refine and give us a little bit more detail about it. Okay, now let's look at the code. In Kotlin, I start off with a series of data classes, classes that will represent each of those inputs and outputs, and I'm making them serializable. I'm using the Kotlin X serialization package, which automatically will serialize data into JSON data and then deserialize it back into objects. So this is just like the one we saw, the Flux 1.1 inputs with the prompt, the width, the prompt upsampling, which I use the serialized name to make sure we convert properly between snake case, the underscores, and the camel case. The seed and the safety tolerance are both nullable, so I made them nullable, and they do have an initial value for that safety tolerance of 2 for whatever it's worth. Here's the async response that wraps the ID coming back. Here's the result response, which has the ID and the status. Status is this enum down here. There's all the individual values for the enum, and the result, which is a sample and a prompt. And I got that mostly by experimenting, because as you saw, they didn't really explain what those were. So the sample is the URL to the generated image, and this prompt is they will give you back the prompt, and I'm assuming that if you do the upsampling, that'll give you a rewritten prompt, although I haven't seen that happen yet. Okay, let's look at the actual networking part. Now, to do the networking, I'm going to use a third-party Kotlin library known as Ktor. K-T-O-R. It's like constructor, CTOR, but with a K. And this is one of the best-known networking libraries available in Kotlin, and it's a framework for building asynchronous server-side and client-side applications with ease. The idea is it works with Kotlin coroutines under the hood, so you don't have to worry about launching them or working about the context or anything like that. You just have to write the suspend functions that are going to be invoked as part of your networking. I only want to use the client here, and if you look at the client, they have a discussion of how all of this works. I do have to warn you, when I first wrote this, it was Kotlin version was 2.3. I don't know, 12, 13, something like that. And by the time I finished writing it about a day later, they had jumped to 3.0.0. And I was worried that suddenly I was going to have to rewrite all my code. Nothing changed at all. It was the exact same API. Now, the server-side code probably would have changed, but the client's still what it was before. Okay, now let's take a look. In my service, I set up the API key as an environment variable that's being retrieved via Kotlin. That's the same code I would use to retrieve it from Java. And then there's the base URL that's going to have the extension on it to do the initial request and then the polling. So this is the HTTP client class that comes from Ktor. This creates an asynchronous HTTP client and a block configuration and so on. I'm using a plugin called CIO, which makes me think of somebody in the C-level suite. No. It's a coroutine based IO system. An asynchronous coroutine based engine that can be used on the JVM, which is what I'm doing, or Android or Kotlin native, whatever. You just instantiate the class with that argument and you're ready to go. I did a little bit of configuration. I added the content negotiation plugin because I'm going to be dealing with JSON data and that'll take care of that for me automatically. I installed a timeout so that I can make sure that I don't go into an infinite loop here. And I installed some logging, which I'm not using at the moment, but is available if you want to try it out. It just shows the requests and responses coming back. Here's the first function that's going to go and create the image for me that triggers the process. I'll send in a request, which will be an instance of that inputs data class, and I'll invoke the post mechanism to go access the request. In fact, what they say here is, It executes a post request at the specified URL and the optional block receiving the builder. Well, I am going to configure it because I need to set the accept header and the content type header, and they make that easy to do. I'm sending JSON data and getting back JSON data. They have a custom header that they defined called x-key. That's where your API key goes, and that has to go with every request. And in the body, by putting in the object, by using the serialization plugin, then it'll automatically serialize my input into the JSON data as needed. Now that's going to return a body, which I say is going to be of type async request. Remember, that's just the wrapper for the ID. So I extract the ID. So that's it. That's the whole initial request to get back my ID. Then I have to poll though. And the polling is going to take that ID, and here comes the fun part, the flow. In the Kotlin standard library, they have a whole section here on asynchronous flow. This is a mechanism built right into Kotlin that says a suspending function asynchronously returns a single value, but how can we return multiple computed values asynchronously? This is where flows come in. If you've ever used reactive streams, reactive Spring, anything like that, this is like that, except that you're setting up the asynchronous calls and then just reacting to the results. In the code here, I did wrap everything in a with timeout or null of 30 seconds. So that's wrapping the whole set just so I don't wind up never returning from it. I do want to cancel it. The reason I did that is because otherwise I have a while true loop. I'm going to keep polling until I get a result from this, unless something goes horribly wrong. So in the while true loop, I'm just doing a get request to the get result endpoint with that ID in it. I'm not sending anything. So the accept header is for JSON data coming back. And there's my key as well. When I get a response back, it's a result response object as we saw. So inside that, I'll look at the status in a when block, and you see there are all the different types of status values I could get. I've got 1, 2, 3, 4 of them that are basically errors, task not found or moderation issues or an error. But the ones that come up a lot, the pending one says, yeah, we're not ready yet, so we will emit this string that says, hey, the task is pending, we're waiting now, and delay for half a second. That's what they did in their sample, figured why not. But when we're ready, then we can access that result, which better be not null. Then we can get the sample inside, which is the URL to the generated image, or throw an IO exception if something went wrong. I wrote a method to download that and save that image. I'll show you that in a moment, and return the string that says the image was saved to whatever the path is of the saved file. So down here, there's my emit if the polling times out entirely. So the emit method is used in a flow to send data back to any listeners. You do have to have somebody listening for this. For me, that's going to be in a test. Just for the record, here's the download and save image one. I'm using the IO dispatcher in order to operate with a disk. And what this is all about is I want to save all of these images with unique names. So I'm making a generated image name of generated image and then a timestamp.jpg, and all that other code is just to format that timestamp. So I create a file under source main resources with that name, and then I'll do my get request to retrieve the generated image. Assuming it's successful, then I'll grab the body and write the bytes out into the file. Otherwise, I'll throw an exception. And that's it. The one down here is just another flow to call everything so I don't have to call the methods individually. Create an input request, admit that, hey, I generated the image now, and then I'll go ahead and call the generate image method, get the ID, tell everybody I started, and then the collect method here is the one that triggers the flow. That's the subscriber, if you will, for the flow publisher. So I'll go get that and emit the status, and unless something goes wrong. So now to run this, let me take a look at the test here. Down here, I ran it inside of run blocking because I'm going to start up a coroutine for this. And I'll just call generate and save image of an ancient tortoise with a party hat celebrating his 100th birthday, whatever. And there's the collect to trigger that overall flow that'll drive the whole system. Let's run it and see what we get. So there's the output of the message, and now we've started and we're pending, and this is pretty typical. It generally takes between 1 and 2 seconds to generate the image. Here it ran a second and a half, and we got back the file. Let's go take a look at it. And there we get a tortoise with a party hat that's got a 100 on it. It's also got a 10 for some reason, so it's not perfect, but not bad. Here's an older one I got, like that. That actually had a nice bold 100 on it. I like that one. And there's the whole mechanism. So let me just show you a couple of images I've generated before. These are a warrior cat riding a dragon into battle. Just have a handful of those. You can see them here. There's a pirate dog, a dog on a pirate ship. This one's walking. Okay, I guess that's good. Another one with boots on, no less. This is a dinosaur rodeo, for what that's worth. There's the cowboy on the back. Everybody looks pretty calm. Cowboy penguins. So you get an idea. This is a really nice image generator. I'm very pleased with the quality of the images that are coming out of this. So I do plan to use this a lot. In fact, I've already used it way more than I expected to. Oh, this, by the way, is the running of the chickens as opposed to the running of the bulls. So down the street, there go the chickens, and here's the guy running with them and all that. These were some orcs on the back of a giant spider. That's pretty creepy, but nice image. Here the orcs are riding ostriches into battle, in formation no less. I had no idea they're going to come out in formation like that. This is a xenomorph playing a stormtrooper in chess. What the heck, let's keep it non-violent here. This was supposed to be a bull in a china shop, and I guess it is. And then my tortoises as well. Another cat riding a dragon. I like that one too, that's pretty good. That's a cat that found itself on a dragon. I don't know what happened with that one. And there we get back to the tortoises. So there's the basic idea. All this code is available. I'll put a link to the GitHub repository in the description. I hope that you found that interesting or entertaining. I do have a different companion video that does the same thing, but in Java. And you may be interested in that, but please subscribe so that you don't miss those videos or any other ones. Thank you very much. Take care. Have a good time.